As you can see, this should look a little familiar. This is some review from last week's lessons on the distributive property. Our objective, or what we're going to be working on, is to write expressions for the total area of the rectangle. Over here, our first question is just an example. So take some time, look at this question, and see if you can figure out what's going on. What's happening in this question? What do these numbers mean in our first example? Take a second and see if you can follow along. Okay, so at the top, I see the area formula. Area equals length times width. Now it looks like I'm also using an area model. I know you guys have seen these back in 5th grade, 4th grade, sometimes back in 3rd grade as well. So over here, I see my length and my width, and I see 5 times x. In the second section of my rectangle, I see my length times my width, 5 times 10. Down here, I've rewritten my expressions, and I have an addition symbol there. Why do you think there's an addition symbol? That's right. Since we need the total area, we need the area of each section of our rectangle combined. Over here, down here at the next step, they've done 5 times x with 5x plus 5 times 10, which is 50. So our goal is to bring it down to this step right here and to have an expression that shows the total area of our rectangle. So now we can look at question 2. I know my area formula is length times width. If I look inside my first rectangle, I'll have my length times width, so 4 times 2x. You can write it in your box if you want, or you can write it right underneath. Now over here, I have my length times my width, 4 times 3. So now I'll have 4 times 2x, which is 8x, plus 4 times 3, which is 12. There we go. Now I'll look down at question 3. I have 4 sections in my rectangle, and I see my length is 7 and my width is s. So I'll have 7 times s, 7 times s, 7 times s, 7 times s. Okay? I can write it as repeated addition, 7s plus 7s plus 7s plus 7s. Or I can look up top and see how many s's I have. 1, 2, 3, 4. Or I can have 7 times 4s. For my next one over here, I have 1/4 times 12. Plus 1/4 times 8. Ooh, don't forget your variable, that r. Now I'll have 1 times 12, which is 12 over 4, plus 1 times 8r, which is 8r over 4. I can simplify, because we've been practicing this a lot, 12 divided by 4, or how many groups of 4 are in 12? That's right, 3, plus 8r divided by 4, or how many groups of 4 fit into 8? That's right, 2 groups. So I'm going to have my 2r. If you're feeling comfortable, see if you can try this one on your own. Maybe you'll pause the video, try it, then click play and follow along to see how you did. 10, 8, y. 8 times 10 gives me 80, plus 8 times 2y gives me 16y. And our last one, we have 5/10 times 20 plus 5/10 times p. You might need to do some multiplication on the side. So I'm going to have 20 times 5/10. 5 times 0 is 0. 5 times 2 is 10. I have one spot after my decimal point. So I get 10 plus 0.5 times p, or 5/10 p. All right, this lesson was just a quick review of what we did last week, seeing if we can look at the area model and use it to find equivalent expressions, to write expressions, sorry. For tomorrow's lesson, we're going to use this area model if you still need it, you still like it, and we'll use that to help us write more equivalent expressions. All right, for Wednesday's lesson, we're going to write equivalent expressions using the distributive property. We can also draw pictures to help us solve. When we draw our pictures, we'll be looking at those area models again. So here, let's practice reading these again. I have 9 times 3x plus z. First, I'm going to start off using my picture to help model what that might look like. I have my rectangle for my area model, and I see I have my 9, which is by itself, so it's going to go on that shorter side. Then up here, I have 3x plus z. And right where that addition symbol is, I'm going to partition my rectangle into 2 pieces. So now, I'll have 9 times 3x plus 9 times z. When I write my equivalent expression, I'll have 9 times 3x, which is 27x, plus 9 times z, which is 9z. These two expressions are equivalent. Now I'll slide over to 1b. I have 6 times 2p plus 5. If I draw my area model, I'll have 6 times 2p plus 5. Right where I have my symbol, I'll separate it or partition it into 2 sections. So now I have 6 times 2p plus 6 times 5. 6 times 2p, that's right, 12p. Don't forget your symbol for your operation, plus 6 times 5, which is 30. If you weren't using your pictures, you can think about how you're distributing that 6 to each of your numbers. 6 times 2p, 12p, plus 6 times 5, 30. Now I'll try this one over here. I'll draw my area model to help me out, and I'll have 7 times 11v plus 8. 7 times 11v plus 7 times 8. Seven times 11v, 77v, plus 7 times 8, 56. So this is my equivalent expression. Next, I have 9 times 3 plus 5 cubed. 9 times 3 plus 5 cubed. 9 times 3, 9 times 5 cubed. 9 times 3, 27, plus 9 times 5 cubed, 45 cubed. And just a reminder, at any time that you're feeling confident, if you think you can multiply without rewriting it down, go for it. If you think you can solve without the area model, go ahead and try that too. Remember, the area model is just here to help you if you need some extra help. You don't have to use it, but it is an option that you have in your math toolbox. Now I have 12 times 10m plus 11. This time, I'm going to see if I can multiply without writing all my steps inside. I'm going to change it up a bit. I have 12 times 10m. Well, I can think of it like my basic facts. 12 times 1 is 12, plus my placeholder 0, and my m. So 120m. Now I have 12 times 11. If you're not sure what that is, you might not have your 12 times tables multiplied. That's okay. You can use a calculator, but I always recommend solving it on your own and practicing. 1 times 2 is 2. 1 times 1, 1. Placeholder 0. 1 times 2 is 2. 1 times 1, 1. 2, 3, 1. 132. So now I'll have 120m plus 132. And my equivalent expression. Awesome. I'll get ready with my area model. I have 10 times 4 cubed plus 11. So 10 times 4 cubed plus 11. I'm going to be multiplying 4 cubed and 11 by 10. So I have 10 times 4 cubed, 40 cubed, 10, 20, 30, 40. Now I have 10 times 11, which is 110. But don't forget to rewrite your expression. All right, we only have 4 more. At this point, if you want to pause and try the next 2 on your own, I recommend that if you're feeling like a thumbs up, you're feeling comfortable and confident, that you pause that video and try 4A, 4B by yourself. Then you can check back in and see how you did. If you still want some help, that's okay. Just follow along as we go through these next questions. So now for our last 2 questions. You don't have to use your area model, but you can if it helps you feel more comfortable. So now I have 4 times 5 plus 6a. I have 4 times 5, 5, 10, 15, 20, plus 4 times 6. 6a. So don't forget your variable. Then, when I rewrite my expression, I need to have my operation in there. So don't forget to rewrite it with your addition symbol. Awesome. Now I have 7 times 8 plus 3w. I have 7 times 8 plus 7 times 3w. Don't forget to rewrite your expression. For these last two, I'm not going to use my area model just in case you have been using it the whole time and you want to see what it might look like without your area model. So I'm going to have 3 times 8g plus 3 times u. So very similar to what might be going on in our area model. That might also remind you of the ones that we had up here. Okay, so now I'll do my 3 times 8g, 24g, plus 3 times u, 3u. And we'll try our last one without an area model as well. I'm distributing that 11 to my 9 plus 7p. So I'll have 11 times 9 plus 11 times 7p. 11 times 9 plus 11 times 7p. And that's it. So we've done some extra practice this week to build on what we did last week. Remember, the last thing due after this assignment is your quiz. Your quiz is going to have questions that look like the questions from Tuesday and the questions from Wednesday. Okay, so make sure you try your best on those quiz questions. All I'm looking for is to see that you try your personal best.